All right, so in this video, we're going to go from having discussed in the previous video the idea of the total cost curve, and we talked about the total variable cost and how it came out of the total product. And now we're going to start moving into the average cost measures and the marginal cost measures. Okay, so we'll start out by, we have a kind of a table here. We're starting out with an initial number of jackets per day, and I'm just giving you the total cost curves. And this table is coming from the book. So again, we have a total cost curve. Remember, total cost is made up of total fixed cost plus total variable cost. So with no jackets, our total costs are 200. So remember, if we're producing nothing, we're undertaking zero total variable costs. So that must mean $200 is still our total fixed cost. When we produce one jacket, we now need labor. We're paying for that labor. We're adding to that labor our total fixed cost of 200. So we have 300. So if we wanted to derive what the total variable cost here was, we'd simply take that total cost, subtract out that total fixed cost, and that would give us our total variable cost. And we can just see that here. If we have total cost equals total fixed cost plus total variable cost, we could just simply say total variable cost is equal to total cost minus total fixed cost. Okay, so we want to keep using these relationships to figure out what values are. Okay, so we have from 0 jackets to 11 jackets, and we have the total cost of production. So what we're going to do is we're going to figure out the average fixed costs. And actually, before we start doing that, we'll just do a quick and easy algebra. We have this relationship between total cost being the sum of total fixed cost and total variable cost. If we divide each element there, so if we're dividing both sides of an equality by the same thing, we maintain that same equality. At the same time, what we can see is total cost divided by output is the same thing. That's our definition of average total cost. Remember, this is still an equality. Whatever we did to the left side, we did to the right side. When we divide total fixed cost by output, we get average fixed cost, and then total variable cost divided by output is our definition of average variable cost. So what we get is from our initial, and I'll erase the division thing here, just to kind of clean it up. So we start out with this relationship and this. We start out with our total relationship. Total cost is equal to the sum of total fixed cost and total variable cost. And from that, we can derive this idea that our average total cost is equal to the sum of the average fixed cost and the average variable cost. Okay, so we'll start. What are our average fixed costs? Well, remember, regardless of the level of output, our fixed costs are always the same. It's always 200. So if we're looking at the average fixed cost, well, it won't make sense when we're producing 0, so we'll not mark that. When we have 1 jacket per day, so we're dividing by the total fixed cost, 200, divided by the number of jackets is 1. So our average fixed cost is 200. We go up to 2. Our total fixed cost is still 200. So 200 divided by 2 is 1. And if we will throw in a couple of more, we do the division, and we get that. So even though fixed costs are constant, the average fixed costs will always decline, because you're taking that same number in the numerator, the 200, and dividing it by larger and larger values of output. So we would expect to see average fixed costs fall. Okay, so we've done the average fixed cost. The next idea is the average variable cost. Remember, average variable cost is simply total variable cost divided by output. And we already mentioned briefly that how do we get the total variable cost out of the total cost? We simply subtract from that total cost the total fixed cost. So here, our total variable cost is 1. So our is 100. So 100 divided by the level of output is 100. And again, this is irrelevant with 0 output. Next total cost, 363 minus 200. So that gives us 163 divided by 2. and we get an average variable cost of $81.50. We proceed, we get $66.70, and then $58.30. And then again, you can fill out the rest of this table or look in the book. But again, we've generated the average variable cost. Okay, next item, and again, we don't worry about the zero value there. So we want to figure out the average total cost. So our definition of average total cost is simply total cost divided by output. So pretty straightforward. We've already got the total cost here divided by 1. Our average total cost is 300. We take our next value, total cost of 363 divided by 2 units of output, and we get 181.50. We do the next one, we'll get 133.30, and just to complete this column, we get 108.30. So again, we've used our definition, our equation, to generate these numbers. But I want to also point out, we derived this relationship before. We said, as a result of simply dividing both sides of the total cost equation by the level of output, that we came up with a relationship between that average total cost is equal to the sum of average fixed cost and average variable cost. So let's check that out. Does our average total cost equal the sum of average fixed cost and average variable cost? Well, 200 plus 100 is 300. 100 plus 81.50 is 181.50, etc., etc. So we've shown that we get a consistent result. Total cost, average total cost, by simply dividing total cost by the output, or simply summing the average fixed cost and the average variable cost. Okay, so that takes care of the average cost. But now we want to look at the idea of the marginal cost. This is probably the most important thing that we're going to do here. So the key relationship here, or the equation, our marginal cost is simply the change in total cost divided by the change in output. Okay? So we're just going to worry about what's the equation and then calculating. So you'll notice these cells are a little offset because we're saying, what is the marginal cost as we move from 0 output to 1 output? Okay? So according to our equation, we want to look at what's the change in the total cost. So 300 minus 200 is going to give us 100, divided by the change in the output. So that's 1 minus 0 is 1. So our marginal cost is 100. Let's look at what's the marginal cost of moving from 1 jacket per day to 2 jackets per day. Again, we're going to look at what's the difference between these two total costs. So 363 minus 300, we get 163 divided by the change in output. 2 minus 1 is 1. So we get $163. If we're going to the marginal cost of going from 2 to 3, 400 minus 463, that gives us, and then dividing it by the change in the output, which again is 1, we'll get, oh, I'm sorry, there was a mistake here. This is 63 divided by 1, so that's $63. And then for this one, we get 37. And then the next one, we get 33. So again, our average costs are kind of saying, how are we doing so far? Kind of thinking about our marginal product, average product. This marginal cost is that forward-looking measure. I won't worry about the interpretations right now, but I just want you to start looking at those parallels between how we calculate and how we interpret a marginal cost with respect to the marginal product.